Okay, let me welcome all of you back to another session of organic chemistry. In today's session, we are going to conclude our discussion of chapter 23, which focuses on carbonyl condensation reactions. But before we do that, let me just a couple of announcements. I want to remind you that the next class exam, that is exam number 4, is scheduled for next week, Thursday. That is April 24, and that is the last day of class. And also, in addition to that, the graduating seniors, your final exam will be on Wednesday, April 23rd. That will be at 6 p.m. In room G8. Okay, so for the graduating seniors, you have to take 2 exams. The final exam, which is on April 23rd at 6 p.m. And then, of course, the regular class exam, which is on April 24th. Okay, because of that, there will be an online review session for exam number 4 on Monday. That is April 21st at 8 p.m. So there will be an online review session Monday, April 21st at 8 p.m. So I will send you a reminder on that. And also, since this is the last full week of the semester, our own work assignment, instead of being due tomorrow, will be due on Sunday. That is for chapter 23, end of chapter 23, questions in our. That will be due on Sunday, April 20 at 11 p.m. And that will be the last our assignment for the semester. Okay, so now let us get started with today's session. I know you get, yes. It's a combination of ACS type question and regular questions. It should be a combination. Okay, so I know you guys want to go over the quiz questions that you have just taken, so let us do that before we continue with chapter 23 discussion. Okay, Matika, can you go ahead and read this for us?
There's an oxime that sodium hydroxide and ethanol, right substance for the 2 Aldol condensation products, one of which is methyl ketone. Write a mechanism for the formation of methyl ketone products.
Okay, thank you. So what you have here, you are supposed to start with 2,7-octane dione, and of course using sodium hydroxide and ethanol as solvent. Okay, this will be, of course, this will be an Aldol condensation. Then you are supposed to write the structures of the 2 possible products. Okay, and one of them is a methyl ketone, and of course, then you are also supposed to write the mechanism of the methyl ketone product. Okay, so let us take a look at the starting material. So you are starting with this. That's 1, 2, 3, 4, 5, 6, and 7. Okay, so you are supposed to start with this ketone here. And then, of course, using hydroxide, the hydroxide could come in form of sodium hydroxide or potassium hydroxide. And then you are also using ethanol as solvent. Generally, when we do an Aldol condensation, we use hydroxide, and we also use some alcohol as solvent. Very often we use ethanol. Okay, so what I want to do here to make this easy for all of us, let us go ahead and label this number, these carbon atoms here. Of course, this is a symmetrical molecule, right? That's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, I do have some questions for you. Okay, now you're supposed to get two products from Aldol condensation. And you know, when you do an Aldol condensation, one of the carbon will be an alpha carbon that will generate an inolate anion, and then another carbon will be a carbonyl carbon that will be the electrophilic carbon. So in this case, which of these carbons will generate the inolate anion? Does it really matter? Which one? Okay, just give me a number. Which one? 3? Okay. Okay, so if we say we are going to generate the inolate anion here, right? So what in essence you are telling us now is that if we generate inolate anion here, therefore we are going to join these two here, right? And then we form a carbon-carbon double bond between carbon number 3 and carbon number 7. Is that clear? Okay? So if that is the case, we are also forming a ring system. How many carbon atoms in the ring system? How many? 5. 1, 2, 3, 4, 5. So let us go ahead and do that. Because all they want us to do is write the product. Okay, so if we say this is carbon number, this is carbon number 3 here, so therefore, I'm sorry, this is carbon number 3 right here, so therefore, the carbonyl is attached to that. Okay, so let us see here, let us number this. So this is our carbon 1, 2, and we say this is 3, therefore this must be carbon number 7, right? Okay, so therefore this is carbon number 4, number 5, and number 6. So if that is the case, where do you expect the double bond to be? Between 3 and 7, okay? The double bond has to be conjugated to the carbonyl, okay? Okay, the double bond will be here between 3 and 7 because that is what the carbon number 3 is the nucleophilic carbon. Once you generate the inolate anion, and carbon number 7 is the electrophilic carbon. Okay, so therefore, okay, now is something missing on carbon number 7. What is missing? A methyl group, exactly. So the methyl is here. So that would be your first product. Now, another way we could also ask you this question, we could give you this product here. Let's call this product A. We could give you this product here and ask you to give the starting material that gave the Aldol condensation product. Okay? So in that case, you have to recognize that you have to keep this right here. And this is the nucleophilic carbon, and this carbon here will be your carbonyl carbon that gives you the electrophilic carbon. Okay, now there are supposed to be two products. What would be the another possibility? What is the other possibility? Where can we generate the inolate anion? Yeah, do that. Huh? One? Yeah, okay, very good. So if we generate the inolate anion at 1, therefore, what you'll be saying here is that you are going to join this carbon here to 7, right? So the carbon 1 will be your nucleophilic carbon, and carbon 7 will be your electrophilic carbon. So therefore, how many atoms within the ring system of this new compound? How many? How many? 7? Okay, very good. Okay, so that is 1, 2, 3, 4, 5, 6, and 7. Okay, so let us do that. Okay, so we are joining now 1 and 7. So if we say this is 1 right here, if we say this is 1, right? Okay, therefore this must be 7 right here. Okay, we are joining 1 and 7. And so if that is the case, our carbonyl will be here, which is carbon number 2. Okay, so that is 1, 2, and this is 3, this is 4, and this will be 5, and this is 6. So where do you expect the double bond to be? Where do you expect the double bond to be? Between 1 and 7. Very good. Between 1 and 7. Okay. Now, is there anything missing here? What? What is it? The methyl on carbon 7. Very good. So therefore, this will be the two possible products, A and B. So far, so good? Okay. The two possible products, A and B. And of course, let's finish the numbering here. This is 7, and this is 1. Okay, now they also ask you to give the mechanism for the product, for this product here, for the methyl product. Okay, so let us do that. Okay, so the products will be A and B. Everybody agree? Now let us take a look at the reaction mechanism. Okay, the first thing we do, we start with what is the first thing that happens? What is the first thing that happens? We form inolate. What is going to form the inolate? Hydroxide, right? The base, okay? So the hydroxide comes in. Now you guys say to form the inolate on carbon number 2. So let us go ahead and, carbon number 3. Put this here. So this hydroxide comes here. We'll grab this proton here, and in so doing, the proton will leave a pair of electrons on the carbon. So we form this intermediate inolate anion. 6 and 7. Okay, and then what happens next? What happens next? The inolate will attack which carbon? Carbon number 7. Very good. Because this carbon here will be your nucleophilic carbon, okay, and then of course the carbonyl carbon here will be your electrophilic carbon. Okay. So doing the pi electron goes to oxygen, and then we form this intermediate. Okay, this is carbon number 3 right here. Okay, and then we lose that, and then we have this here from the double bond here. Okay, and that would be your alpha. Okay, so that would be the mechanism for the production of A, and that is your A right here. Okay, so anyway, the point here is when you do the Aldol condensation, the first thing you do is to generate the inolate anion, and then the inolate will act as a nucleophile to attack the carbonyl, which is be an electrophilic carbon in this case, in this particular carbonyl here. And then eventually you are going to lose water. So we are losing water here. Okay, so let us go to the next. Okay, Frederick, can you read this for us? Okay, thank you. So in this case, now another case of a reaction mechanism using ethyl acetate and ethyl propanoate provide a mechanism for a mixed Claisen condensation reaction. Okay, so you need to know what those starting material are. So this here using ethyl acetate, which is this here. Using ethyl acetate and ethyl propanoate. Use a different color here. To give a mixed Claisen condensation. In this case, you could use any one of these since they simply wanted to give an example of a Claisen condensation reaction. So, which one do you want to use for your nucleophile? Which one do you want to use for the nucleophile? The ethyl propanoate? Okay. Okay, let's do that. We want to use the ethyl propanoate. So therefore, let's start the mechanism. Okay, so we start with this. Okay, so the first thing you do is what? What are you going to do first? From the inolate, okay? So we use the ethoxide to form the inolate because we are using an ethyl ester. So therefore we come here. The ethoxide will be acting as a base. We'll grab this proton here, and in the process we are going to generate the inolate anion on that carbon. So we form this. Now, since we want to use a mixed Aldol condensation, so now what do we want to do now? What do you want to do now? Use the ethyl acetate as for your electrophilic carbon. Okay, the carbonyl on this here. Very good. Okay, so that comes here. So now we have this. Keep in mind you have non-bonding pair of electron on oxygen to start with. Now we have the ethoxide is still here. Now we have this is attached, so we have this here. Okay, so now what will happen now? What is the next thing that happens? We will form the, okay, so this is a case of nucleophilic acyl substitution reaction. Okay, so we are going to reform the carbonyl, and in so doing, keep in mind carbon is tetravalent, so we are going to lose, break one of these bonds here. In this case, we'll break the bond to oxygen, release the ethoxide, so now we form this. Okay, plus ethoxide is formed right here. And now what happens? What happens at this point? The ethoxide will come in, okay, and pick up the proton again to form another inolate. Okay, so let us draw it so that way. Comes here, pick this up, and then we form, release the electrons to that carbon. And that gives us this here. And now finally, what do you do? Finally, okay, keep in mind we also form, and what? Dilute acid? Okay, very good. Okay, and that will be the product of, keep in mind that in this case, in the Claisen condensation, the first thing you do is to form the inolate anion, and then the inolate anion will react with the ester in an nucleophilic acid substitution reaction, in which essentially you will be kicking out the alkoxide, and the final product will be a beta keto ester in this particular instance. Beta keto ester. Relative to this carbonyl here, this is the alpha carbon and this is the beta carbon. Or you may call this a 1,3-dicarbonyl compound. Okay, that's what you get with a Claisen condensation reaction. Okay, so now let us do the last one. Okay, Edward, can you go ahead and read this for us?
Provide a scheme for the synthesis of ethyl acetoacetic ester from acetic acid.
Okay, very good. So here we need to provide the synthetic scheme for acetoacetic ester starting from acetic acid. Okay, so now that what we want to go from here, acetic acid, and to here. Okay, so what do we do? What do we do? What is the first thing? Now, this is not a case of reaction mechanism. This is simply providing the scheme. What is the first thing you want to do? Starting with acetic acid. Esterification? Okay, very good. So you want to esterify the acetic acid, right? Okay. Why do you want to esterify the acetic acid? Because you want to do a Claisen, very good. Because you want to do a Claisen condensation, you know that for Claisen condensation you need to start with an ester. So the first thing you want to do here is to esterify the acetic acid. And what reagent do we need for that? Ethanol and sulfuric acid. Okay, any acid will do. Do ethanol and let's say sulfuric acid. And that will give you okay, and this is what we call the Fischer esterification. Anytime you take an alcohol, react an alcohol with a carboxylic acid in the presence of any mineral acid, then you say you are doing a Fischer esterification. Okay. Okay, now we form the ester. So what is the next thing to do? Okay, what I will do, I will take 2 moles of this. I will say step 1. What does that do? Step 1. You form the inolate anion right here, okay? Then step 2, nucleophilic acid substitution, okay, which will be Well, I already have two. Let me just say, let me put this here. Let me do this. Start with one. Then the other one will be here. Okay, and step 3 will be dilute acid. That's all you need to do here. Okay. Now, if you want to write the scheme this way, make sure you know what you are doing, because it might be better if you write the scheme step by step. That way, you will get some partial credit if you don't get the overall product right. Okay, but if you know what you are doing, you could do this 1, 2, 3. Okay, and then of course from this. Okay, what does the hydronium ion do? What does the hydronium ion do? Okay, go ahead. Oh, I thought you were saying something. Yes, what does it do? Okay, to protonate the inolate anion. Very good, excellent. Okay, so okay, very good. So now we finished the problem from the quiz. Now let us go back to today's discussion on chapter 23, so we can finish the chapter.
Wait.
What?
I was writing that down.
Okay, so what do we want to do now? Remember, if you recall, when we left on Thursday, we started discussion of Michael reaction and conjugate or conjugate addition reaction. So what we want to do here, we want to finish up on that, and then also conclude with the Robinson annulation reaction. So in essence, two things I would like to do today. One, Michael addition reaction. More examples of that. Then also, I want us to make this very complex molecule starting from very simple molecule. In other words, I want to tie up everything together in one synthetic scheme. I would like us to make this molecule here. Like us to make this steroid, starting from very simple molecule such as acetone, ethyl acetate. In other words, these are the sources of your carbon atoms in this molecule here. Formaldehyde. Okay, I also want to put a methyl here. Methyl iodide, methyl bromide or iodide. Okay, and finally this here. These are the only molecules that you can use for your sources of carbon atoms to make this molecule here. Okay, so let us start Michael addition reaction. Just, I know we started on Thursday, but let me give you a few more examples. If you recall, we actually did discuss Michael addition reaction in previous chapters, but what we want to do in this chapter is use the enolate anion as a source of nucleophilic carbon to perform the Michael addition reaction. So if you have this, remember when I gave you this here. So if you started with this, for Michael addition reaction, you need an alpha beta unsaturated ketone or aldehyde. Alpha beta unsaturated ketone or aldehyde. Or sometimes you might even use an ester or ester. Okay, alpha beta. Okay, this is the alpha position and this is the beta position relative to this carbonyl right here. Now, so if I take this, say I generate this enolate anion, right? Okay, I could generate this enolate anion by taking acetone, okay, and reacting with hydroxide in the presence of ethanol as solvent. You generate the enolate anion, and then what do? This comes here, attach this beta carbon here, and the pi electron goes to the alpha carbon, and then you form this product, or this intermediate product. From an intermediate enolate. Actually, let me go ahead and make this blue. Let us make this blue so we see the. So we have this here, form a new carbon-carbon bond. Okay. And then, at this point, what you then need to do, you want to add dilute acid to protonate the enolate that you formed. Hydronium ion, and the enolate will simply come here and pick up the proton from the hydronium ion. So what have we done here? Of course, let me, we have a proton here already, and that one is still here. So what have we done here? We have essentially added, if you notice, this here, this is what we are starting with. We have added this molecule here. That is in essence what we've done. This part of the molecule goes to here, and this hydrogen goes to the alpha carbon. That is the essence of what we've done. And that is why we call this Michael addition. Because we get from here to here by simply adding hydroxide in the presence of, okay? Okay, so that would be your typical Michael addition reaction. Okay, let me give you one more example of a Michael addition reaction before we go to making our big molecule. Now, if I take this, I tell you, okay, let me use something else. Supposing I take this. And I have this. Generate the inlet. Plus water. And then I take that inlet, keep in mind all you need for Michael addition, you must have an alpha beta unsaturated molecule. Supposing I take this alpha beta unsaturated molecule, okay, what do I get? This inlet attacks this here. This pi electron goes to the alpha carbon. And I have this. Okay, and at this point, what do? I now add the dilute acid to protonate this inlet here. Just come and grab the proton, and this release electron to oxygen, and then I have this is still here, this is here, this is here. Okay, so that is another example of Michael addition reaction. Now, take a look at this molecule here. This molecule that we use here. Supposing I ask you to show me, give me a synthetic scheme for that molecule. How will you make that molecule? How will you make that molecule? Okay, I'll give you a hint. Use an Aldol condensation. Use an Aldol condensation, right? Could very well take this. Acetone, you start with acetone. By the way, acetone, that is your paint remover. That is the same solvent that you use to remove a fingernail polish or paint from the wall, or any time you see any kind of paint. Okay, so it's a very common solvent. Okay, we take this. Acetone again. Supposing I generate an inolate ion here, hydroxide, I generate the inolate ion, and then I react this with formaldehyde. Okay, I react with formaldehyde. Those of you going to medicine or pharmacy, that is what you want to use as a preservative. Okay? Okay, so this is your nucleophilic carbon here, and this will be your electrophilic carbon, and that's what you have here. Okay? You could form this through an Aldol condensation, and you get this product here. So you begin to see where we're going here, starting with all of these small molecules. Okay? Now, supposing now, let us do this. You got this? Okay. Supposing and I have this. One, two, three. 1, 2, 3, 4, 5. Supposing I have that. And I do this. Step 1. And then, of course, step 2. What do you think the product of that reaction will be? What will be the product? What do you think the product will be? Okay. Okay, what kind of reaction do you expect here? Is it an Aldol? Do you expect an Aldol, or do you expect Claisen? You expect Claisen. Okay, if you expect Claisen, very good. That's what we expect. Now you say we could generate the inolate anion here. If we generate inolate anion here, of course, this becomes your electrophilic carbon. So how many carbon is that? 1, 2, 3, 4, 5, 6. So we form a 6-member ring. From a 6-member ring, we say we have this, and then we have this. Okay? Of course, at this point we are losing this. Let us number this. This is carbon 1, 2, 3, 4, 5, and 6. Okay, so in that case, we are joining carbon 1 and carbon 6. So therefore, if we say this is 1, this is 6, therefore this is 2, this is 3, this is 4, and this is 5. Now, if I then ask you, take a look at this molecule here. Take a look at this here. I want you to make this molecule. Okay, if I say I want you to make this molecule using a Michael addition reaction, what will you do? Using a Michael addition reaction. Okay, I want you to make that using a Michael addition reaction. Because there are several ways in which you can do this. I would say, well, save some time here. If it's a Michael addition reaction, I could keep in mind Michael addition reaction, you need a alpha beta unsaturated carbon. So if I clip this right here, if I have the double bond here, and this would be the ester, I form the inolate here, right? Follow that. And then I could do the Michael addition. In other words, I could have this. and this. Right? And now if I take this, to form the inulate here. Okay. Step 1. And then step 2. Okay. This and this will now react to form this here. Okay, you can see where I want to go here. So at this point, we can use this here and this ethyl acetate to form this. Okay, where did this come from? About this one, where did this come from? This one came from acetone and formaldehyde, right?
Which one? The first, yeah.
This came from acetone and formaldehyde. Okay, in an Aldol, so here you are using an Aldol condensation. So here, this is Aldol condensation. To give this, and from here to here, you are using Michael addition. Okay, and from here to here, we are using what? Claisen condensation, right? Okay, now, supposing now, and I'll take this, take step 1, LDA, step 2, what do I get? I protonate carbon 1, right? I mean, I alkylate carbon 1. We're getting close to making our steroid. Starting from very small molecule. Okay? Okay, now, we have made this. Now everybody knows how we made this, right? Starting from those small molecules. Now let us take this ketone here. Let us take that ketone. You got this? If I do this, hydroxide, or alkoxide, step 1, and then I add a Michael addition, a molecule. We made this already. If I do that, what do I get? I get this. Follow this very carefully now. What have I done here? This is a Michael addition reaction. Okay, you follow that? Okay, of course, this here, let me add the step 3, you add. We form this. Now supposing now I take this molecule here, and I want to do an Aldol condensation. Okay, suppose it and I do an Aldol condensation. Okay, what happens? I pick up the proton from here, I form an enolate, right? That enolate will attack this carbonyl here. You form an aldol. This here, this carbon here, is this carbon, okay? So now we form an aldol. Now if you you apply heat, then you form this molecule. Okay, this is the product of your Aldol condensation. Okay, now so what have we done here? From here to here is Aldol condensation. Now the combination that we just given you here, a Michael addition reaction plus Aldol condensation, this is what we call a Robinson annulation. Robinson annulation, which is equals to Michael plus Aldol. So anytime we say give me, if I say give me a Robinson annulation, that means you need to perform a Michael addition reaction followed by Aldol condensation. So now this sequence here is what we call a Robinson annulation. Annulation means ring formation. You are forming a ring. I'm going to borrow 5 minutes from you guys today. Almost time. Okay, this is what we call a Robinson annulation. Now, this particular molecule here, this ketone here, we also refer to as Weyland Mice-Chef. Weyland Mice-Chef ketone. It's a very important ketone. We use this ketone here to make all those steroids that are very important pharmaceutical drugs and also natural drugs, natural molecules. Now, let us now take this. Let me take 5 minutes of your time. Yes. See that? Yeah, this ketone here is what we call Weyland Mice-Chef ketone, this here. Okay, so if we take that ketone, you got it? Okay. The ketone I'm just giving you with this one here. This is the same as this here. If we just turn it around. Okay. Now, if I take this ketone here,
Is that an equal sign?
huh?
Those three lines?
Which one? Where? This here?
The three lines.
Oh, yeah. In other words, this is the same as this. You know, all I did was just, turn it around. That's all. Let me say same. So now we have this here. Supposing now I take this, I take this here, the assignment I have for you, if I take this alpha beta unsaturated ketone, the assignment I want you to do at home, how will you make this using an Aldol condensation? Okay? How will you make this here, this molecule here, using an Aldol condensation? Supposing I take this here, and then I do a Michael addition. Step 1 and step 2, I do a Michael addition. What do I get? I get this. So I do a Michael addition. And then I follow this up with Aldol condensation. In other words, I want to do a complete Robinson annulation. Then I do an Aldol condensation. Okay, this here, this will be your nucleophilic carbon right here, and this will be your electrophilic carbon right here, right? And therefore, I will get this product. Okay, and then finally, if I want to do alkylation, step 1, LDA, step 2, I could alkylate this carbon right here. Keep in mind there is a methyl here, and then what do I get? This carbon right here. I pull off the proton from here with LDA, and then so this is the highlight of your study of organic chemistry. This is it for you at this point. You become an expert in synthetic organic chemistry. Now you have this. Okay? Now you make, starting from very simple molecule, you now make this steroid right here. So I will ask you, starting from acetone and ethyl acetate, if you can do that. Okay, now take a look at this. Take a look at this. This is the male. This is the female steroid hormone, and this is the I'm sorry. This is the female, and this is the male. Isn't that similar to what we just made? So now you will make steroids and start selling them in the commercial market, right? If you now open up your own pharmaceutical company or your chemical factory, right? So anyway, folks, this is the highlight of your study of organic chemistry. You started with very small molecules. We are able to make very complex molecules. So when we come back on Thursday, there will be a short quiz on today's. There will be a short quiz on today's presentation, and then we are going to finish up with chapter 24, which will be a fairly short chapter. Yes. Our will be due on Sunday, on the 20th at 11 p.m. And that is the last hour assignment. Yes. Okay, go back.
I'm going to go to my room and see. I thought you were in there. Just remember that my mom and daddy bought the ticket for that.
Huh? Two slides, okay.
I think you was talking about this one right here. You see the two small molecules that might be like microaddition.
Which one? This here?
Right, where you see microaddition. Is the microaddition like those two structures go into that picture?
Yes, microaddition would be this here. These two. That's Michael. Because what are you doing? You're making the inolate here, and then you add into this carbon-carbon double bond. Yeah. Okay. So this is Michael. Okay. Just a minute.